Now let's work with problem 1.10. A certain one-particle, one-dimensional system has a potential energy V to be equal to this and is in a stationary state where psi of x is, and B is a constant, and C is equal to 2 nanometer inverse squared, and mass is 10 to the negative 27 grams. So we need to find the particle's energy. So we have a potential that depends only on x and not on t. And we say we are given the information that the system is in a stationary state. So this implies we can employ the time-independent Schrodinger equation. And the time-independent Schrodinger equation is it's time-independent, so this would be the equation. Or in other words, the energy of the system can be given when you divide the entire equation by psi of x. So this is how we compute the energy. So we have the potential V, we have the psi of x. What we need to do for now is to first compute the second derivative of psi of x. So let's get started with that. Before computing the second derivative, let's compute the first derivative. Now that would be, psi of x is given here. So let's take the constant out. Now we can, so we need to apply the derivative of a product rule. So it's going to be derivative of x times e to the negative cx squared. That will be b times. Let's first take the derivative with respect to x. So we get this plus b x times. Now we take the derivative with respect to exponential, which gives us back the exponential times this. So to simplify this, we have this. That is the first derivative. Now the second derivative would just be taking a derivative of the first derivative. So this term, the derivative of that would be this. And here we need to apply the product rule. So let me first take the derivative of x squared. So that would be 2x. Now I'm going to take the derivative of the exponential, which will be this. So let's simplify the terms and see if something can be clubbed. For x squared, I have negative and negative would be a positive. So 4b have c squared x cubed cx squared. So this will be the second derivative. And we see that we have 2bcx here and a 4bcx here. So these two can be combined to give me a negative 6. So I'm just gonna change it to that. So this is the second derivative. So we have computed the second derivative of psi, and we can write this as, I'm gonna take bx and the exponential term out. Give me 6c plus 4 c squared x squared. And this term is nothing but psi of x times 6c plus, sorry about that. So it's nothing but psi of x times negative 6c plus 4c squared x squared. So if I were to go back to computing the energy with all of this information, it would be times, this can be written as psi of x times 4c squared x squared minus 6c plus a v of x. So I'm going to beautifully cancel the psi of x terms here. And I am going to write this as h bar squared by 2n times 4c squared x squared minus 6c plus we have the potential, which is 2c squared h bar squared x squared by m. So this can be combined to give us negative 4 h bar squared c squared x squared plus 6c h bar squared plus 2c squared h bar squared x squared. Actually, it won't be 2 plus 4 because I'm gonna take the common denominator. Okay, so we have identified this form of energy and we have a beautiful cancellation here. The 4c squared h bar squared x squared and negative 4c squared h bar squared x squared can get canceled, right? So this would mean the energy is 6c h bar squared over 2m. This can be written as 3c h bar squared over m. All we have to do now is to plug in the values. And c is 2 times nanometer to the power. So I'm going to write square meter squared times h bar is nothing but h over 2 pi, right? So when we have h bar squared, we're going to have 6.626 into 10 to the negative 34 squared divided by 2 pi squared is nothing but 4 pi squared. And the units here are joule squared second squared. And in the denominator, we have the mass, which is given by negative 10 to the negative 27 gram. Or I can multiply it with 10 to the negative 3 and call it kilogram. Now let's see how the units work out. So I'm sorry, here we have a negative 2 because it's nanometer to the power negative 2. So we have a negative 2 here and a negative 2 here. So we have meter raised to the power negative 2 joule square second square per kg. Now, the unit of energy is clearly a joule. So I'm gonna put a joule here and write a joule separately. Now, a joule is nothing but Newton meter, right? So I'm gonna expand this joule in terms of Newton meter, which is kg meter per second square times, it's a Newton meter. So now the kg and the kg gets canceled. Meter square, s square all get canceled. We clearly end up with a joule. Now for the numerical part, if we plug in the values, we get 6.679 times. So if we just multiply and divide everything except for the powers of 10. Now I'm going to club the powers of 10 together. That will be negative 9 times negative 2 is going to give me an 18. And here I have negative 68. And from the denominator, I have plus 27 plus 3 joule. So energy is going to be 6.679 into 10 to the power. We have 18 minus 68 plus 30. So that's negative 20 joule. So the energy of the system is given by this value.